Hey guys, in this video we're going to talk about doing a quick attach bucket conversion on a standard Kubota bucket. So there's several different ways to start. I use the latch plates from Titan Distributors. It's basically just this back plate here. Comes with, the pin and the mechanism, um, all of this, and that's 190, I think it is. And they weigh about 40 pounds to start with. And then I also purchased from Titan Distributors as well, like the $100 quick attach plate, and I cut it off. It used to have another section here, but I wasn't going to use that for my setup. So they also sell another configuration that is already built up like this, with the spacer and the crossbar and everything. And that one weighs like 120, but it's another $100, which this is a lot of work just for $100. Except that it can't be delivered. It's like another $75 delivery fee as well. And that one weighs 120 pounds. These plates weigh 40. And this entire setup that I put together ends up weighing 80. So because I have a smaller machine, I wanted to try to make it as light as I could and not lose any extra lift force. So I decided on just going with just the basic plates. So the total cost for what you're seeing here was like 190 for the plates, $100 for the quick attach plate, and then these spacers here. That's a 3-inch square tubing, 1/4-inch wall. I got 3 feet of that for $60, and then basically all the rest of this, like all these extra pieces were just out of my scrap bin that I had from other stuff. So the old weight of my bucket was 150 even. That backing plate adds like 40 pounds, and this entire setup here is 80 pounds. So I ended up I sacrificed 120 pounds of my lift force for the quick attach, which isn't really that bad for the versatility that it gives you. So when you're putting these together, originally it wasn't clear. When you get these in the box, these handles are attached, but they're not attached in the right way for the boxing. So you have to figure out how to flip the handles all around and see how you want the mechanism to work as you go. And also, you don't know that you need a spacing plate. There's no instructions or anything. So I ended up proceeding the cardboard mock-up of the whole thing to start with because I wanted to see. I have a smaller bucket. I wanted to see what all the alignments look like. So, I marked out where the edge of the plate was going to be based on the width of the bucket and the width of the plate, and then splitting the difference. And then I figured out where my rams were going to be. So, I have like 1 inch of clearance in here between the edge of the plate. And also, I wanted to set it up. I wanted things to be as easy as I could for alignments and stuff. So I just put the spacer and the brackets right on the edge of the quick attach plate. And what that gave me down at the bottom, this is a little old at this point, so it's falling apart. So what that gave me down at the bottom was the pin was going to be coming basically in the center of the opening down here. So, I have 1 inch of play this way. And then if you cut this back, I cut this back far enough that I could be 1 inch off this way. So my pin is by default here if I'm perfect, and it can be here or here. So, we have a range to work with, and we've cut this back. I ended up cutting this back like 4 times because I kept taking the minimum off. So what I did is the final measurement from here to here for me was 9.5, and from here to here was 12. And, maybe this will help me. Like, if I'm off, maybe that'll help slide in a little bit. I don't know. We'll see. So let's see. What else did I want to cover? The on the attachment mechanism itself, and there's a blog post on all of this that shows you how I got all my alignments and everything, and shows all the pictures along the way. And I'll post that in the comments below. So a couple other notes on, the latching mechanism. So this spring will compress. It rides in on a bevel against that bottom edge over there on the cutout. And that spring will compress a little bit. And right as it goes over center, it's a toggle action, and we can adjust how far over center it goes. I use the fine thread because I wanted, a fair amount of threads into the side piece. Um, and then that's adjustable with this nut on how much of a compression you get. And well, I'll get to that in a minute. So we got one stop there. When you're putting this together, you'll notice that, this bar it's not centered on the ears, and it can't be because you have a clearance consideration right there. So, you have to, what I did is I welded up, the two sides on the tractor, tacked them into place, and then I put this bar in, and I played with this mechanism to show where this plate had to be. So I had the proper clearance on both sides because I'd rather just weld it once instead of having to start torching stuff out later. And then we also have another stop up at the top, and that's about when this is at 90 degrees here. And if you go over that, then this mechanism will bind and it won't go down nice. And this upper spring is for tension. This is the way that the handle's staying in the upright position right now. Otherwise, it'd want to fall back down and stuff. And for that, I just welded in another piece of plate up there just to kind of keep everything together. You can also see in one of the gussets that I put in from the square tubing to the upper thing, I put holes. So this is how I'm going to mount it onto the tractor. I'm going to use the engine lift to lift it up, get it into place, and then I can put the pins in and stuff. Right now, the commercial ones that you buy, the through tube goes all the way through, the riser and stuff, and it's an open end for water drainage. I have it welded pretty good, but, unless you are specifically welding for watertight, you can't count for it. So I'm probably going to drill holes in, because this is boxed in as well completely. So I'm going to drill like a 1/4-inch hole, here and here in the bottom side on both ends, just in case any water ends up making it in there. Because I also had to join two pieces together right here. My piece wasn't quite long enough, so I'll just account for assuming that we're not completely watertight. And then let's see, for the plate, when I mounted it here, originally is in my bucket. The bottom edge of my bucket ear right there was lined up with this bottom edge, with this fold in the bucket. And I wanted to try to keep my geometry as close as possible for like dump angles and stuff. So, I lined this plate up. I lined this plate up, the crease in this plate with a fold in the bucket. And the way I got my plate completely square to the bucket itself, which is, mandatory if you want your bottom cutting edge to be parallel to the ground when you're done, is I just took a piece of angle iron and I put it right here coming through this hole on both sides. And the plate was cut well and the bucket wasn't tweaked. And I double checked my measurements in other ways, but that was the simplest way to line this plate up parallel with the cutting edge on the bucket. And then I did other measurements just to double check. And then I tacked it in place. And then I dumped the bucket and, made sure that my alignment was right before I went crazy welding that, because I would not want to cut off. If I had to cut all that off again, your bucket's pretty toast. You're cutting out a lot of stuff there. So to get the tabs off the bucket, I just used a cutting torch. I cut them right off, right through the bucket. You can see on the inside of the bucket, there's this one got a little messy here where the angle iron was, but, I just cut it right through and then re-welded it on the inside. I also took the time to put a couple extra tabs in there for like a clevis hook or something, in case I'm using like ratchet straps. So, let's see what else. Oh, so taking these tabs off. So once you torch it out, then you still have the layer of bucket plate and a whole lot of weld left onto the bottom of these. So then I had to set them upright, stand it on something, and then take the torch and cut all the extra weld off. And I had like goober size things of slag by the time I was done. It was a messy job. Then these are completely crispy critters because all the paint has gotten completely fried at that point because of all the heat going into it. So these have to be stripped on the inside as well as outside. So by the time you get these tabs off, somebody says, "Oh, you just cut the tabs off and re-weld them on." Yeah, that's like at least a half day's labor right there of kind of crappy, smoky work. So don't take that entirely lightly like I did. I've been building things for a lot of time, and I still underestimated how big and messy the whole process was going to be. And then the whole process of painting it is, there's a lot of nooks and crannies and enclosed places, and so the whole thing is it's a long process. I've done this over the course of about 2 weeks as I've been coming out and tinkering with it in mornings before work. So one other thing that I wanted to cover is, so these blocks, there's a piece of threaded rod in there, and I haven't entirely looked at the mechanism. I got to take it apart. But sometimes when you're coming down, I really have to horse on it, and it feels like these threads are biting into this block before they start to slide. So, and I mean, this is still dry. There's no grease in there, and that could be part of the problem. But I'm going to take all that apart, see if there's any wear on any of the threads where they are binding, and grind them down if they are. Or it could also be, I guess it's not a slide in there. So it's just those threads sliding through this block to give it when it reaches the compression part. So I probably just have to smooth out some of these threads because it feels like they're catching on the block and, really chewing in there like teeth and not going down smooth. So that won't really be a problem because there's probably only half an inch of adjustment here that you got to worry about, and all the rest of the threads are not going to be in use anyway. So once you figure out the adjustment point, then you can, or maybe even a layer of grease will take care of that, and that'll be the end of it. So I guess that is everything. Long project, came out well. I probably did a little bit more work with like the cardboard mock-up and stuff than I had to. Oh, the reason you have to use the riser bar here is because disassemble this fire quick. So the reason you got to use the riser bar in there, and it's not clear front that you have to, but you do, is because of this kick out. If you just welded this straight to your plate down at the bottom, as nice and as tidy as that would be, you're going to be, this part here, when you go to full dump, is going to hit the back of your loader arm. So I ended up going with, the height of the kick out, basically, a little bit over. So you can see that down there, but that'll give you the clearance that you need in order to do this. So I think that's all the design considerations that I had to go through with, taking the measurements and putting everything together and figuring out how to do this. I couldn't find any build videos that went in depth on this stuff, so you just kind of have to figure it out on the fly. So hopefully you guys will find this video and it'll help you out a little bit. So, all right, take care. Thanks.